Let's do a problem on area between two polar curves. This is taken from openstacks.org, Calculus Volume 2. This is a free resource, so you can easily find this online if you want some additional practice problems or if you want to follow along. Okay, so we're going to do number 209. We're going to find the area. So let me scroll up. It says, for the following exercises, find the area of the described region. So then number 209, find the area of the common interior of 4 sine 2 theta and r equals 2. All right, so let me go into OneNote now. So if it's helpful to watch how I'm thinking through the problems, how I'm approaching it, I'm going to slowly go over it. Okay, so let's first sketch these two curves out. Do we recognize what these two curves are? This is a circle centered at the origin of radius 2. This is the petal curve. Okay, and how many petals does it have? Well, this number multiplied to the theta is even, so that means we have 4 petals in this one. Remember that stuff? Honestly, I don't think it's too important to know the categories, except for, like, you should know what r equals some number is. That's a circle for sure. And then the other ones, if you don't remember it, you can easily just sketch it out to get the general shape. That's what we really need. We need to know how these curves look so we can find the intersections and all that. Okay, so let's do the circle of radius 2 first. That's easy. Whoops. Something like this. 2 minus 2. Okay, and then for this petal one, if you don't remember, we can always just do a table of values. So when theta is 0, we get 0 for r. When we plug in theta is pi over 4, we get r is 4 actually. When theta is pi over 2, we get r is 0. Okay. So this is actually one petal right here. We see that at theta, whoops, I keep accidentally erasing, at theta equals pi over 4, so theta equals pi over 4 somewhere over here, it's the tip of the petal. And remember, this circle is of radius 2, so it's going to go further out to somewhere over here, let's say. Okay, and then at theta equals 0, it's at the r is 0, so it's at the origin, and then it's increasing in radius, so something like that. And then afterward, it decreases in radius back to the origin, because r goes back to 0 at theta equals pi over 2. So there's one petal, and if you recognize that by symmetry now, you can probably just sketch the others. Something like this. Very rough sketch, very ugly sketch, but we just need to know in general how it looks. So let's look at the common interior. Let's even highlight it out. Here's 1, here's 2. Oh, I don't want all of that. Here's 1, here's 2, here's 3, here's 4. And you can probably guess by symmetry, all the 4 individuals are equal in area, so we can just find one of them and multiply by 4. If you really want, within that 1, you could even just find half of it and then multiply by 8 for 8 total halves. But I'm not going to do that here. Okay, it might be easier, but I'm going to explain my thought process through this and my preferred way. Okay, so we need our points of intersection. Let me go back to the pen. We need to find what this point is right here and what this point is right here. Those will be important limits of integration. So let's set these two polar curves equal to each other. 4 sine of 2 theta is equal to 2. So sine of 2 theta is half. So theta could be, what we got, or 2 theta, let's first do that, could be pi over 6, 5 pi over 6, so on and so forth. But when we divide by 2, we get our 2 in quadrant 1 from just these two, between 0 and 2 pi. Okay, so 5 pi over 12. Okay, so these are two important limits of integration right here. Okay, so now with that, let me explain now. Well, when we traverse this area, we're going to first traverse the curve, the petal curve from 0 to pi over 12. We're going to be finding part of the area there, area bounded by that polar curve, okay? And then from pi over 12 to 5 pi over 12, we're going to be bounded by the circle. And then when we go from 5 pi over 12 to pi over 2, we're going to be bounded by the rose petal again. Okay, so we got to set up three integrals. So it'll be it's half r squared d theta. So half integral from 0 to pi over 12. Let me write that a little better. Of the rose petal, so 4 sine of 2 theta squared d theta plus half integral pi over 12 to 5 pi over 12. It'll be the circle, so 2 squared d theta. Okay, and then plus, I'm not going to write it because we actually argued, I hinted at this earlier, the area bounded by this part of hopefully you can see, this part of the petal is the same as, so from pi, 5 pi over 12 to pi over 2, the area bounded by that part of the rose petal is the same as the area from 0 to pi over 12. Okay, so we can just multiply this by 2, so 2 times half is 1. Okay, and then this gives us the common interior for one of the four, so we need to multiply everything by 4. So this is our setup right here. Okay, let me start erasing so I have some space. And let me shift this over as well. Okay. Let me shift this upward as well. Okay. So we have our setup. Now let's start evaluating. Equals 4 bracket. So this would be 0 to pi over 12. We can put 16 out in front. 4 squared is 16. Sine squared of 2 theta, d theta, plus 2 squared is 4, so it'll be 2. 4 over 2 is 2, so 2 integral pi over 12, 5 pi over 12, d theta. Okay. This integral right here is easy enough. It'll just be 2 times 5 pi over 12 minus pi over 12. Okay, fundamental theorem calculus. So then doing the subtraction, that will give us 4 pi over 12, right? So that would be pi over 3, actually. And then we can just multiply the 2 pi over 3. Okay, and then now the sine squared theta, how do we evaluate this integral? We need the half angle identity. So it'll become 8, then 1 minus cosine of 4 theta, d theta. Okay, so I'm going to swap the order. So 2 pi over 3, and then plus 8 times theta minus the 4th sine of 4 theta. Evaluate this from, what was it? 0 to pi over 12. Okay. Or maybe let me use parentheses over here instead. Okay. All right. So then we get 4 times 2 pi over 3 plus 8 times pi over 12 minus the 4th times sine of 4 times pi over 12. That's sine of pi over 3, which is root 3 over 2. And then when we plug in 0, everything will go away, right? So then this becomes 4 times 2 pi over 3 plus, what would this be? 8 pi over 12, that is 2 pi over 3 again. And then 8 divided by 4 is 2. And then there's a divide by 2 there, so then it becomes minus root 3. So this becomes 4 times 4 pi over 3 minus root 3, which if we want to distribute, that is 16 pi over 3 minus 4 root 3. There's our answer. Let me see if this matches what I got previously. Looks like it does. Cool. Okay, so here's a more neater version if you want to see. All right, but that's how I thought through the problem. First and foremost, sketch, points of intersection, and then we start setting up the half r squared d theta integrals. All right, hopefully this was helpful. Please stay tuned for more practice problems if you're interested. We'll be going through a few more.